Hello and welcome back to a new lesson. Today I will talk about resistors, how to select a resistor to your design, and what are the main differences between them. If we go to Schematic and search for resistor in RCL Library, we will find many different types of resistor, through hole and SMD ones. So, what's the difference between them? And how you can decide which one to use. So, how to choose a resistor? There are many aspects to consider, like mounting type, resistor material, power rating, tolerance, and finally, your application requirements. Let's start with mounting type. There are two major types: surface mount, known as SMD, and through hole, known as THT. Through hole are simpler to design and assemble to the PCB, while SMD is better for mass production and to save spaces in your design. For SMD packages, I will use the imperial values as a reference, like 0603, 0805, etc. Bigger the number, bigger the size of the resistor. Second aspect is resistors material. Carbon resistors are the standard, while the metal and the metal oxide are more better in terms of tolerance and the maximum power rating it could handle, and will be less affected by temperature changes, which make them more suitable for applications requiring a high endurance. SMD resistors are constructed from a metal oxide with a ceramic body and have a similar characteristics to metal oxide resistors. MELF resistors consisted of a metal alloy material and consider more better than typical SMD resistors in terms of the power rating and stability under high temperature environments, but they are more expensive and cost more to assemble due to the cylindrical shape they have. Power rating. You might ask yourself why there are bigger resistors than another, since they have the same resistance and maybe the same material type. The answer is the power rating. Power rating is the maximum amount of power that the resistor can withstand, and simply to calculate the power applied on a resistor, we can use this equation for DC voltages. Before going any further, let's talk about Ohm's law. Ohm's law is the fundamental law for any electronic circuit, and this law illustrates the relation between the voltage, current, and resistance. Named after the German physicist George Ohm, this law is very useful to calculate the current you will get in your circuit. And the formula is voltage equal the current multiplied by resistance. The relation between the voltage and the current is proportional. When we have fixed resistance, increasing the voltage will increase the current flows in the circuit, etc. From this law, also we can calculate the current and the resistance if we manipulate the original formula like this. The power formula is another derivative of Ohm's law that we'll use to calculate the power dissipation and how to select the correct power rating resistor for your application. We can see some pictures for THT resistors with different power rating. Most SMD resistor will have a power rating less than 1 watt, so be careful to this aspect when you design your PCB. Alright, let's take a simple example. If we have a 12 DC power source supplying a 100 ohm resistor with a power rating of 1/8 of a watt, can this resistor works in this circuit, or it will burst into flames? Using our beloved Ohm law, we can see the current flow in this circuit is 0.12 amps, which means the power on the resistor will be 1.44 watt. And since this resistor is only 1/8 of a watt, so it will be destroyed immediately, and we should use at least 2 watt power rating resistor in this case. Tolerance. Well, tolerance is the percentage of error in a resistor's resistance. Resistor comes with 0.1 error and up to 30% error. Let's take an example. 10 kilo ohm resistor with 10% error can be any value between 9 to 11K. Some resistors will be affected by the temperature changes and could change the resistance value based on the ambient temperature, specifically the carbon resistor. From the color code, you can recognize the resistor's tolerance for THT resistors. Check your resistor dimensions. Always pay attention to the size and the dimension of the resistor you have. If we check these 02, 07 through hole resistor, the only difference between them is the dimension between the endpoints or the soldering points. It could be 7, 10 or 15 millimeters. They all the same component, and the difference in the way you will bend the resistor to match this footprint. Also, you can measure the resistor you have on Eagle and check its dimension with your resistor in real life and with a datasheet of the resistor you have. Finally, your application requirements. With all the aforementioned aspects, you can decide the suitable choices for your design. What is the maximum size of your design? Do you need to save some spaces? What's your PCB application? Is it a power supply or a telecommunication board? What's the maximum voltage and current you have in your design? Also, the price of the components could be a very important aspect. Since resistors not so much expensive themselves, the assembly for THT components is higher compared to SMD components for mass production. But for small quantity, SMD is a bit harder to solder them compared to the THT components, if you want to solder them by yourself using soldering iron, for example. So that's it for today. I hope this quick demonstration will help you to understand more about resistors. Nonetheless, you need to search more about it, since there are many types of resistors and applications for them. Thank you so much for watching. See you next time.